So hello guys. So yesterday we studied this and a research tool to derive new relation. We use dimension as a research tool to derive new equation. How we saw one example yesterday. Which example? The example was deriving the gravitation. Simple pendulum formula, which was T is equals to 2 pi square root of L by G. Yesterday we derived this. Just we saw the dependency of simple pendulum. Simple pendulum, simple pendulum, which is depend on this mass and this length and gravitation due to Earth. We have these three constants. So we derive this formula. This formula. Now we will continue our class. We will continue our class by this. See, before that, I want to tell you one thing. I want to tell you one thing. Dimension of some quantities which are like sine. Whatever, if you have sine inside bracket anything, or exponential inside bracket anything, or log of inside bracket anything, for this kind dimension is always equals to 1 1 1. Remember important condition for sine, maybe cos, tan, cot, anything trigonometry in bracket, it's equals to always 1, and exponential is equals to always 1, and logarithms equals to always 1. Important thing. Okay, now by this we can solve this kind of problem. See, if they are given one formula which is f v square divided by b beta square into log of e into bracket 2 pi beta divided by v square. Now for f is equals to 4 they are given, f is equals to 4, v is equals to velocity they are given. Now and they said to find the dimension of this alpha and beta. This one formula they have given, and they have said us to find this beta dimension and this alpha dimension. How will you do? Just common sense needed. Common sense needed. See here, you have one small trick which is log of e 2 pi beta divided by v square. Anything inside the log bracket is equals to 1. Anything inside the log bracket, just now I said, anything into the log bracket is equals to 1. So how can you write? Now you can write 2 pi beta divided by v square is equals to 1. This 2 and this beta is constant. This 2 and this is constant. Constant. So constant value. Constant value. Now what remains? What remains? What remains? Beta divided by v square is equals to 1. Now I can write beta is equals to v square. V is equals to what? Your velocity, which means beta is equals to, what is the dimension of velocity? Velocity is equals to distance by time. Distance is equal to length by time, which means L into t to the power of minus 1. Now if I write here L into t to the power of minus 1 into whole square, now our beta becomes L square t to the power of minus 1. Now just we find beta. Just we found beta. Now we want our alpha. Very easy. Very easy. Very peria easy. Chinna problem with peria easy tricks. This equals to 1. So this is constant and 2 pi is constant. We remains only b divided by v square. We know velocity. We can find beta. Now we got beta. We got beta. Yesterday I said for any problem, if they are given like this, that time alpha is equals to this one and alpha is equals to this. Yesterday I said, now we want alpha value. So I can take this one. I can take it. Yes, I can take only this one. Alpha is equals to f v square divided by beta square. Beta square. Now force. What is the dimension of force? Force is equals to ma. Ma. Mass in m. Acceleration t to the power of minus 2. Write it. Write it here. Sorry. M L t to the power of minus 2. Force dimension you are written. Now velocity square. Velocity square. Velocity square. It will be like this. Velocity square. Now you have beta value here, beta value. Substitute this beta value here. T square to the power of minus 2. Now you can cancel some things. This one get cancelled. And if you closely see this one get cancelled. Yes, of course it will get cancelled. Now what remains? What remains? One. Here 4 right, beta square. Sorry, beta square. I have just taken beta. They are given beta square. Beta square. Beta square. Okay. Now, if you carefully see, total answer remains is m to the power of 1, L, t to the power of 0. Understood, or someone wants to repeat this stuff?
Repeat, sir.
Yes, sir. Don't worry, sir. Don't worry. See, very simple thing. Force dimension we have. Force is equals to MA. MA dimension. M means mass. Acceleration dimension is this. Simple. Now I will write here force dimension. Now velocity square dimension they are given. Velocity is equals to, velocity is equals to distance by time dimension here. But here velocity square they have asked, which means L square t to the power of minus square, velocity square. Similarly, beta square they have asked. Beta, we have just now find the value, which means beta square becomes L to the power of 4 t to the power of minus 4. Minus 4. Now we can cancel some things. Can we cancel some things? Yes, we can cancel. See, 1, L1, L2, which means L3. Cancel this, cancel this, cancel this one. Now t to the power of 2, t to the power of 2, t to the power of 4, t to the power of 4. Cancel this one. Now what remains? M and 1L and t to the power of 0. T to the power of 0. Okay. Now this is the dimension of alpha. This is the dimension of beta. So simple topic. This kind of questions they will definitely ask. One question, write it. 4 marks, one question from this for NEET 100%. Not only this kind of question. Okay. Okay. So understood, guys? If anyone wants, I can repeat once more time. Or else I will move on. Okay. So next question. Limitation of dimension analysis. Limitations of dimension analysis. Some not only limitations, you can say like we are calculating these values, alpha, beta values. These only limitations of this dimension analysis. The position, for suppose, see, the position of a particle at time t is given by relation. There is one any particle, let's say your chalk piece particle, at time t, the relation given for the chalk piece is this one relation, where V naught value is constant. V naught is constant. Remember, V naught is constant they are given. And is 1 is greater than 0. Find the dimension of V naught and this one. Now how to find? How to? See carefully, there is one more small thing in that. If you carefully see, there is one more small thing in that, which is that e to the power of minus alpha t. Right? Exponential. Anything to exponential is equals to 1. Just now we discussed. Which means your alpha t becomes 1. Always remember, when we are writing this exponential in dimension, the negative will ignore. Negative will goes. Okay now. Now alpha is equals to 1 by t. Now alpha is equals to dimension becomes t to the power of minus 1. You got your this dimension. Now we want dimension of V naught. V naught. So simple. Again, what I will write? I will say extra day class. This one is equals to this, and again this one is equals to this. Now we're done with that. This one. Now we have this value, which means we can use this to calculate your V naught value. To calculate your V naught value. V naught value. V naught is equals to, I can write like this, x of t alpha. Yes, I can write it. Just cross multiply. Fine. Super, super. Now, after this, what happens? What happens? X value. X. See carefully. X to the power of t. X in the bracket of t. X in the bracket of t. Don't get confused. Now, most of the students will write it, take it as time. No, 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 no. See carefully. Distance at a time. Distance at some time. Distance at some time. Which means here we are seeing distance at some time. Which means we have to take this one as distance, not time. Which means V naught is equals to distance measured in L, and alpha value we have here t to the power of minus 1. Is this the dimension of velocity? Yes. Is it dimension of velocity? Velocity is equal to distance by time. Distance measured in L, time measured in T. So, very easy. Whatever the constant velocity value is also same as velocity. Super. Anyone doubt in this? Uh, Ani?
Sir, once again, sir.
Yes, super. Once again. Once again from start. See, first try to understand the question. The position of particle at time t. Position of particle at time t. See, in this, which is main, on which particle is dependent? Distance. Particle is dependent on position. Time is secondary here, but the main thing, this particle is depend on position. If we have position, then only we can see time now. So basically here particle is depend on position. Mind in your, keep it in your brain. Now they are given one relation, this one relation, this one relation, and they said v is constant, v naught is constant, v naught is constant, and your alpha is greater than 0. Find the dimension of v naught. Now we want to find dimension of this and dimension of v naught. How can we find? Very simple. If you closely see this one, e to the power of minus alpha x, you have a small trick. This is basic. Which means just now we discussed, see here, e to the power of anything is equals to 1. Which means e to the power of anything is equals to 1. Now, if you have this kind of function, you will write only power, not sign, is equals to 1. Now, we want this value. I will send this t downside. Now, what happens? T measure in time. Time. It is in numerator. If it come to, sorry, it is in denominator. If it come to numerator, it becomes to the power of minus 1. Now, we have dimension of this value, this value. They asked dimension of V naught. V naught. How to find V naught value? So simple. So simple. See, yesterday we discussed one small thing, which is like whenever you have a small function, this function is always equals to this one and is equals to this one. Yesterday itself I said, one more time I will say, it is like V is equals to U plus AT. Which means your velocity dimension is equals to u and velocity dimension is equal to at, which means this dimension is equals to individual of this one. If you want, we can see velocity is equals to this one. This is also initial velocity, same. Now at, a is equals to l t to the power of minus 2, and you have t1 t extra, which means this becomes again same. So the thing is, this side always equals to individual of this side. Okay now. Now which means we can take here individuals. La 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 la. Individuals. Individual. I will take this one. Individual. Okay. I want V naught value. Then I can send this to that side. Okay now. Now V of t into alpha. We have this value, this dimension is here. I want this one dimension, sorry, this x r, x. Just now I said it is position of a particle at time t, position of a particle at time t, which means it's depend on position. If you have position, then only we can calculate time. which means here basic is position. So position is basic, which means I will write, see, in normal students will take as time. No, it's wrong. See the dependency. It is depend on position first. So I will write position. Position means distance. Distance means length. And this value we have already this side, t to the power of minus 1. Your V naught dimension is equals to this, is equals to this. Now is it right? Yes. V naught is equal to velocity only, right? Velocity may be constant or moving. Velocity is equals to what? Velocity is equals to distance by time. Distance measure in L, time measure in T, it will become same. See, velocity value is dimension this, and constant velocity, whatever constant or moving, if dimension must be same, we got same. Now clear, guys? Now clear?
Yes, sir.
Super. Now after this, there is small problems. Yesterday we discussed same problems. Now we will see significant figures. What do you mean by significant figures? Anyone, any idea? Geo, Airtel, anything? No. I will only tell. Significant figure means I think you are writing values like 2.314 or 5678 point something something like that. That kind of figures we call significant figure. Let us see first definition. Significant figures is a measurement of value of physical quantities. See, significant figures is a measurement of physical quantities, tells the number of digits in which we are confident. In which we are confident. Very simple. We have a number. For suppose let us take from your home to our school. It is 5 kilometers. 5 kilometers. You are telling it is 5,000 meters. Your confidence it is 5,000 meters, or you are telling 4,899 meters. So that numbers are there now. This kind of numbers, we are confident of a value. We are doing an experiment. We got a particular value. We are confident about that value. Maybe up to, for suppose let's say 3 point sorry 4,348 meters is I am confident. Above this I don't know. Above this I don't know. The values up to which we are confident, the values up to which we are confident is called as significant figures. So simple. And see, the larger the significant number obtained in measurement, greater the accuracy of measurement. Now what is this? Now what is this? Larger the significant numbers measured in experiment, greater the accuracy of measurement. How? What? What this simple? Very simple. Now just imagine you have done one experiment. You got value. You got one value like 95.7. This you got value. And one more you got value 9.54358. Now which one you feel very confidence value? This one or this one? Of course, this one you feel confident because it has large number. Large number. Now, in if you go for showing your illustrator, if maybe this is wrong, maybe this is wrong, but here is a huge number, it becomes right. So, if you measure many times, your value will increase, and as the greater value, as this number increase goes on increase, your measurement will be accuracy increase. Measurement accuracy will increase. So simple. Significant figure is a figure or number up to which we are confident of. That's it. You are doing one experiment, you got one value. For suppose, let's say you done one experiment, you got a value 57.32481,347, something. Now your confidence up to this value only, this value. You don't know this value. This is true or false, you don't know. That time you will only write this value. Your confidence up to this value, so you will write only this value. This kind of figures are called significant figures. Significant figures. Now there are some rules to see significant figures. Rules. Rules. How we will say a number is significant, or in a number how many significant figures are there. There are some rules. What are the rules? See, all non-zero digits are significant, or all non-zero, sorry, all non-zero digits are significant. What it's saying, all non-zero digits are confidence. We have confidence in non-zero digits. See, one example, for suppose 43.3. All are number, which means in this significant figure is 3. No matter points, don't see point. Just see how many numbers are there. 42.3, 3 significant figures. And for suppose 24.123. In this how many significant figures? 5. Number, 5 numbers. We are confident of 5 numbers. That's why we are writing 5 numbers. Similarly, you can say 5.123. Now here significant figure is 4. Okay now. So when you have this kind of number, then significant figures become 4. Your confidence up to 4 digits. You are only confident up to 4 digits. You don't know extra digits. Okay now. This is first rule. Write down. Now second rule. A zero between significant figure if appear sorry, a zero becomes significant. A zero becomes significant if it appear between two non-zero. Now what it is? Significant means we are confident, we have number, we are confident, we have two numbers. In between, if I get zero, then I count this zero also as significant number. Then I count that zero also as significant number. Let's see one example. For suppose example 5.03. 5.03. Now 0 is between this number and this number. If you have number, which means it is significant, which means 0 is between two significant number, which means here this kind of zeros we take it as significant only. For suppose in a bench, this side, this side and this side, two idiots are there, then the center person will also become idiot. Okay now. So here significant figure is 3. Now similarly if I take 4.004. Now in a bench, last side idiot, this side idiot, this two will becomes idiots. 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 4. Now just for you remember, whenever you see a number, mark it as idiot. Idiot. And take one bench, your class bench, and imagine this side one idiot sitting, this side one idiot sitting. Whoever sits in between these two idiots will become idiots. Okay, now simple. Now this rule over. First rule, all numbers are significant. Second rule, zero between two significant number is significant. Now leading zero or zero placed next to the once again zero placed next to the left. This one is left left, mark it as left of the number are significant. Zero place next to the left of the number, zero place next to the left of the number or significant. Now what they are saying, zero place to the left of the number. Now see, if I have this kind of things, that time hey, what a nimsham now. 1 minute, guys. Guys, just 1 minute. There is some mistake in this sentence. La la la. Some mistakes happen. Uh. Now it's right. Never be significant. Oof, oh. Sorry, guys. Adjust. So zero place left to the number never be significant. Just simple. If you have like this, you will never count this one. You will never count this one. You will never count this one. This kind of thing significant figure is only 3. Now, if you take one more example, let us take 0.001. In this condition also, significant figure is only 1. Just simple. There is one bench. Now here three idiots are sitting. Here is one good guy. Three idiots. What happens? he will fall down now. 3 idiots making fun of this guy. He will go from there. Similarly here also, there are 3 idiots. They will make fun of this. It will go outside. It's become only 3 significant. Now here, one idiot, 3 good boys. He is making fun of all this. So they will go from here. Only one significant. Just the simple thing is, whenever you see a zero, left side, you never count it. That is not significant. Okay, now zero between is significant. Zero left is not significant. Fine, now super. Now 3 properties over. Fourth property, trailing zero. Trailing zero or zero place right to the number or significant. Same simple case, opposite to that case. This one is opposite. This last case was whenever zero is left side, we never count. Whenever zero is right side, we will count. Now trailing means what? Trailing means time, ending. See, I will take one example. For example, 434.00. Now these zeros are to right side. These zeros are to right side. This kind of zeros we will count. We will count. Now significant figure becomes 5. Now one more example. Now here also 0 is right side. We will count. When 0 comes left side, we never count. When 0 comes right side, we will count. When 0 comes in between two significant, we will count. 4 properties, easy properties, over. Now see, in exponential notation, the numerical portion given the number of significant. In exponential notation means what? Some values like 10 to the power of minus 2. Exponential. It is like e to the power of x, right? Similarly here, 10 to the power of minus 2. Exponential values are exponential notation, the numerical portion given the number of significant. Which means if you have this kind, you never count this one. Whatever the value in front, you will count that one. See, in numerical exponential, I will write one example. Wait. If I write example, you will understand. If I write example, you will understand. Now define. In exponential notation, this is one exponential notation. We have some exponential here. Okay. The number portion gives the numerical. The number portion gives the number of significant. Which means in this kind of things, only this gives the significant number. Which means your significant number is 3. 3 3. Now if you have number whatever 10 to the power of 8 or 10 100 something, you will never count this one. You will only count this one. Now significant number is 3. Okay, now when you have value like this, some numerical value, you only see significant of numerical. You will never see this one. Okay now guys. Okay. Now last one, the number of significant figures are clearly mentioned and do not change on changing unit. Do not change on changing unit. See, so simple. The number of significant figures are clearly mentioned. For suppose you are calculate, you got some significant values. Okay, now for suppose see, you measured one value, you got 1.5 meter. Length is a physical quantity. You got this significant value. What is significant? How many significants are there in this? Two. Two significants. Two significant figures. Now they are telling, if I change this unit, then also significant number will be same. Significance number will be same. How? Let's see. For meter I can write 1.5 into 10 to the power of minus 2 centimeter. Now do we count this value? Never. See, never ever we count. Which means in this significant figure is 2. Significant figure is 2. Let us see one more example like this only. For suppose, let's say you have walked 5 kilometers. 5 kilometers. Here significant value is 1. Only one number. Now if I convert this to meters, it will become 5 into 10 to the power of 3 meters, right? Now significant value is 1 only because you won't count this value. You won't count this value. Understood all rules. Boys, girls, if someone is there other thing. Understood guys?
Yes, sir.
Easier, easier.
Yes, sir.
Yeah, super.
Yes, sir.
Yes, yes, super. Now there is one more thing, rounding. Rounding. I think we can't cover rounding now. So if someone has doubt, let me know because rounding is a little lengthy topic. In next class, we will end this. Rounding, errors, we will end this. Don't worry. In next class, your first chapter will be over. Thank you.